So the point is that now we sort of before the end of the training session, we discuss about the projects and what was going well and fast and was easy, and maybe say where we are at the moment and if there are one or two main key issues that we need to solve, and see whether it will be super easy or not super easy. And then the idea would be that we take some time, like in 2 weeks, 3 weeks from now, so that we have time to complete a bit the project, and then we will present the project one to each other, and then discuss about the final results of everything. Okay, so this will be in some weeks from now. So for the moment, it's just a brief summary of what we did and where we are. Okay, so who wants to start? Okay, shall we go, Cara?
Yes.
Okay, so Cara, can you just in a couple of words,
Yes.
each of us actually summarize what was the project in a couple of sentences, and then explain where we are.
Okay. Well, I can begin.
Yeah.
Okay. So my project is the aim is to apply the gravity on the tree, on the whole tree, for simulating its growth under pressure of the gravity. So what I do is that the next I went from an existing code from a recursive tree, and also an existing code which calculates the pressure on a single branch. So the aim now is to apply all of the results from those two code base, and produce the gravity effect on the whole tree. So the step where I am now is here. I can have my whole tree, but the gravity is not applied yet. We can see here I came directly with an error which is smaller than the minimum error I give for the deformation. So the goal for me now is to understand more how the gravity is applied on the tree, and also how I can manage to take, the evolution of Apex in each stage of production. Yes, in case you understand something in this project, your ideas are welcome, and if you have any question on it, I can try my best to explain it to you.
Do you want to integrate growth, or do you want just to apply the gravity once the tree is built already?
Yes, here is in fact the point. The gravity or the pressure is calculated now in taking account that we have the whole tree.
Okay.
It's calculated in this way. So I adapt my code also to this. Then I generate the whole tree. Then I calculate the pressure and apply on it. Yes.
And then a step of growth, and then reapply the mechanics.
Yes. In case there is a growth, of course.
Yeah. Okay.
Reapply it.
Okay. Great. Would you like that we go up to the point, because now the bending is in one plane?
Yes.
So we assume that branches will bend always vertically.
Mm-hmm.
But it actually, as the branches, they may get out from the main plane of the bearing branch,
Yes,
it may be that there are moments of torsion on the branch.
of course.
Would you like? Do you think that we might go up to this point in the end,
Yes,
where we
but
take into account the torsion?
yes, yes, it will be better to integrate the whole three-dimensional gravity on it. Yes, on it. But I think the best thing for now is to well integrate this one, the one-dimensional pressure gravity on the tree, and after that we can take a step, another step for integrating the three-dimensional gravity.
Okay. Thank you, Cara. Other questions to Cara?
Yes, Evie.
Yes.
So, Cara, so here you're only trying to integrate the gravity forces on each branches.
Yes.
Okay. And but do you integrate also? So as you said, it's not gross; it's just static.
Yes. Once the tree is built, then I apply the gravity. It's like that.
Okay.
But it can be if we assume that the step at which the growth is occurring is much slower than the step at which gravity takes its action, then we could decouple the two. And it may be that we make, for one step of growth, after each step of growth, you do a step of gravity bending, and then you alternate step of growth and step of gravity bending. And then in this way, you would have gravity acting on the growing tree. Is that clear, Fabrice?
Yeah.
Okay.
I was also wondering, because in the process of growth, you can also model the fact that a plant is orienting the growth against the gravity. So you have gravity perception and gravitropism.
Yes, but
Yeah.
So this will create the pass basically of the tip. And I'm
Yep.
asking this question because so for example here you could say that more or less trees, they look like this, okay, like the bending of the curves are very regular, okay, and they make like smooth curves, but for our Arabidopsis plant it's much more wavy in a way, and I think it's because like growth and gravity are much rapid, or at least growth is much faster, and you have a constant oscillation of the tip between different stimuli, so which is gravitropism, but light, and so you have I think a very dynamic oscillation of the tip depending on different stimuli, and then when you have this wavy behavior of the tip, the stem is growing, and then the stem incorporates this waviness, and later on, like it is smoothened by growth and gravity.
I think
And so
you're right.
Like
There was a paper, a series of paper in the beginning of years 2010.
okay.
That were presenting a very abstract and high-level way to introduce this gravity, the sensing of gravity, and the fact that the branches would fight against gravity by reorienting themselves. It was rather easy model, that I would say. So maybe one thing, once you have done the work, it would be not so difficult to integrate this other aspect and see whether we can obtain branches that are winding a bit. It would be interesting.
Yes. Okay.
So it could be a last step in your project.
Okay. Okay. Well. Okay.
Okay.
We'll try this once this step is over.
Okay. Great.
Well, thank you.
The paper you are referring to, is it also linked to the more recent work of Bruno Moulier and Olivier Amand about proprioception?
Yes, it's actually it was a work from the group of Bruno Moulier. It was by Renaud Bastien.
Yeah.
So,
Yeah,
so,
that
so
was the one
please,
I was thinking about.
could you put the link
Yes.
in the discussion?
I will provide you after the class
Okay.
all, rather extensive bibliographic list so that you can really get many relevant papers
Okay.
like
Well,
this one.
well.
Okay.
Thank you.
Who wants to continue? Maybe Arthur, just mention your project, where you are, what you want to, how you intend to address.
Okay, my project is also on the mechanical simulation of deformation of a plant, H3 for me. And so while Cara did this inside the L system, the L string system, I'm more on an approach where I'm between each round of simulation. I take the resulting L string outside in the and each function. From this L string, I'm building back some sort of structure of tree structure that have a convenience function for mechanical or deformation calculations. And then with the structure, I can do so the static resolution of the forces for each segment. Then I will be able to do deformation calculations, and then propagate those deformation back through the tree.
Okay. Okay.
And finally, giving back a parametrized L string that can be interpreted with deformation.
Yeah, great. So while Cara is making the computation within the L system, you would make the mechanical computation outside of the L system world,
Yeah,
and
outside.
see, and then we could compare a bit what are the advantages and the drawbacks of different approaches. So good, super. Thank you, Arthur. How about you, Jeanne?
I can show you, but I don't know if it's very interesting at this point. But
It's quite cool.
Even if you don't, Jeanne, even if you don't have results, you can just give what is the aim of your project, and then where you are and where you want to be.
so my final goal is to model the entire life cycle of mosses. It actually just starts from a spore, from which is going to emerge a filamentous network called the protonema. So for now, that's the step I am at. So I make emerge 3 filaments. They're gonna explore the space with a random angle at every growth step, and then they're gonna start branching. And the mechanism that took me some time to understand is the self-avoidance mechanism. So where a filament detects another one in his vicinity, it's gonna stop growing. So if I play, we're gonna see the filaments growing. There is some branching. Branching is also defined by a probability function. So basically that's it. And the next step would be to make the leafy shoots grow in 3-dimensional space, because for now it's just on the 2D plane.
It's super. There was a crossing over of segments here.
Yeah, actually, because how it works is that there is divisions at the apex. It's developing through tip growth, but cells grow with a hill function. So even if it stops dividing because it encounters a filament, the growth of cells inside the filament might make the filament overall
Okay. So
cross.
maybe you would need to find some ideas about this.
Yeah, but I'm thinking, it's part of the noise of the system.
Okay.
In the wild, the filaments don't stop growing exactly when they encounter another one. It's I don't know exactly
Well,
how
at least
it
they
works.
don't enter one into the other.
No, but that's because we are in 2D. In a 3D, in the
They
soil,
would
they
go-
can
okay.
tangle up a little.
Okay. Great. Any questions?
So this is the primary stage of the mouse,
Yes.
and what is the next stage after?
Like maybe I can. I had a paper not too far. So from the filament. So here are the filaments, and here are the branching filaments. And at some point, a bud emerges, and from the bud there are rhizoids, kind of analog to roots, and so. Biologically, it's very interesting because there is a change in dimension of the organs, because the filamentus is just a line of cells and the gametophore is from a tetrahedral cells, and it divides to make a 3-dimensional structure. So from the protonema that I was showing before, bud is initiated, and then it's going to grow with a stem and leaves and branch, and there are the sexual organs are going to develop, and when they are fertilized, there is the sporophyte that's going to grow. It doesn't look anything like the rest. It's just one stem that is darker usually, and with a capsule where the spores are, and when it opens, the spore can spread, and once again we have development from the spore and the protonema. So I'm hoping to model the entire life cycle, but
Nice work. Good. Thank you very much, Jan. Nabil?
My project was to model the saffron flower. And thanks to Christophe, I have understood actually how is the structure and the branching works in ELPI, I think. Actually, I'm struggling about how can I create the different elements in a way that will have a sense in biology. So I don't know, for example, if the leaves will appear through time, or it will be initiated at the beginning. So, and my goal is to make it as close as possible to what is in reality. So I have to introduce the saturating growth of elements. And make it more realistic.
Okay. Great. Super. We are waiting for the result. Maybe André Claude?
Yes.
Yes.
So I've been working from the paper showed by Christophe and by Clark and Lee, where you had the drawings with inflorescences. It doesn't work. From different setups, and I've been trying to recapitulate, so to say, the different schematics from using one model, trying to to go through parameter changes rather than model changes to go from one model to the other. From what I've tried and what Christophe mentioned, it looks like I still need to have some switches, so to have state analogs, at least one, maybe two of them, to basically to distinguish the case where you have just a flower growing with a pericell, or actually secondary branches, which is further dividing that thing. And it seems that the overall, in terms of parameter, this is very sensitive to the low you put on the internode growth with respect to the appearance of a final plant you produce.
Is there good hope that you find a model that would integrate a bit all these architectures?
I don't know. I had something, I lost it, so maybe I will find it again.
Okay, good. Thank you very much, André-Claude. Then Fabrice, is it okay for you?
So in my case, it was much easier because I started from an already existing model. So the idea is to take the latest Arabidopsis model from Christophe, understand it and tune it the way I like, to so that the plant look a bit more how I would like it to look like. And so, for example, so I've been through the code a bit, trying to understand how it works, trying to manipulate it. So my first hello world exercise was to suppress, for example, the branching. So that's what I did today. So here I can recreate a typical fishbone as we are imaging. Okay. And then, so now the idea is to, now that I understand how it works, the idea is to incorporate some of the real data I took and to understand where they are. So for example, so what I did was to create a list of all the parameters I would like to incorporate, the real measure I have, and where in the code I should write it. So for example, so with a very simple example, so I have a plastochrome data. Okay, sorry. So for example, here you can see that the real data I measure. So here I'm just plotting the number of new silic at each time point. So then the derivative of this curve should be the plastochrome. Okay, so now I'm trying to parse my data to automatically compute the plastochrome, and when I will have the plastochrome from this experiment, I could reinject the plastochrome here in the code where I identified. Oops, sorry. So that's the factor T in the code. So I go back to yeah. So that's a general idea.
Sorry, we didn't get your last sentence.
So yet.
Can you repeat the last sentence?
So the last sentence was once I treat my data with a kind of statistical analysis, I can put a mean plastochrome here instead of this arbitrary value here, which is not an arbitrary value because you take it on purpose, I guess.
Yes. Right.
But I can fit this plastochrome here with my data. And then we have to discuss how to incorporate like a noise or variance, let's say, in it. Okay. And so here I took the plastochrome because it's easy. But you have like a number of other parameters that are not that easy, I think, to know where they are in the code. So for example, the number of floral buds that are present in the inflorescence buds, so the point I discussed yesterday. And I think here is just, for example, a question of delay between flower development and internode development. And so first we have to discuss whether that's a good way to implement this. And if yes, I have to find where to modify the code to incorporate this behavior.
Okay, thank you. Questions to Fabrice? No. Fabrice, do you have the impression from your first analysis that what you did with your measurements in the field are enough, or there are lacking things? There are things that are lacking to inform the model. What's your impression?
I think that there is one parameter I don't have. It's more about internode dynamics. I think in the growth dynamic of individual internodes, because what I measure is the growth dynamic of an entire stem or an entire branch. Let's say axis in general. And the problem is that those axes, they are made of several internodes. And then they are a composite structure with internodes of fixed size at the base and growing internode at the tip. And so I have the behavior of the entire structure of this composite structure. But in LPy, what we infer we control the parameter of one internode, and then it's not easy to understand how by playing with the behavior of one internode one by one, I can reach a target behavior for the entire stem. I don't know if it's clear.
Yeah.
So right now, for example, if I just share my screen like this. So yesterday I presented you the fact that I had like growth curve. Yes. So is this, for example? Okay. So do you remember these plots I showed you yesterday? So here I can compute a growth curve. So between each time point, I can compute the growth rate of the main axis of the Paraclete 1, 2, and 3. But then how can I translate this into the model? I have no clue. And I think it's not the right way to do it. I should have a better understanding of how exactly in the main stem, for example, where the stem is growing. And I guess that at the base, it's not growing anymore. And there should be a transition in the stem where internodes are still a bit growing. And yes, like so this each internode will have a different growth dynamics along the stem. And I think I should try to understand this.
Okay.
I think for this, the work done by Howlin with Frank and I last year could be useful. Well, it needs a bit of work, but it could be useful to automatically extract the growth dynamics of each internode.
Yeah, you're right. Yeah, okay, good point. Maybe we have some data like this.
Okay. Thank you very much, Fabrice. Mona?
Okay, so my project was simulating the growth of bell pepper. It's in the very initial states of just having the architecture of it, but I hope to put it into the continuous growth such as we saw for Arabidopsis. But for now, we can see in general it follows the structure of the bell pepper. For example, the sympodial growth having a terminal flower, and also how the growth of the plants are perpendicular, which I don't remember what we called them.
Which one?
Decussate. Yep. And so the first thing is I would like to make it more realistic, and also to incorporate the growth of the buds, which I haven't incorporated here now, and to also make the growth cycle and put it into that cycle. So yes, for now it's in this stage.
Super. What was the main difficulty until now of creating this?
So for me, it was, which is still a difficulty, as we can see, is to like give the sense of gravity for the fruit. So as you can see, it's like it's kicking in the air, but I wanted to like be like more realistic. And
Okay.
after like playing a lot with the tropism and angles, this was the best I could get it. But it definitely needs some more work to understand like how I should incorporate the tropism within like the fruit. And because the fruit is composed itself of 3 parts,
Yep.
which I made, like it has like the 3 different parts, like a little branch, and then here, and then the fruit itself. So at first I connected these, and then incorporating it onto the branch. It's a bit difficult to like move everything, and then to put the gravity only on the pedestal of it, or where on the branch I should put it.
Questions to Mona? Mona, I didn't get exactly. You want to integrate the dynamics in your model? I mean, from
I
the.
want to have like the continuous growth that we had, for example, for Arabidopsis, because it's, as we saw like the video together, I think it will give it like a really good aspect of, for example, for us for the point clouds, and also like to incorporate the random sizes of the internals and also the buds. And
Yeah,
how
yeah,
it like goes.
Yeah. Would be super. Yeah. Agree. And about the, do you think for the realistic rendering we need a bit of texture?
Yes, as I think, I can't share it more. We saw together maybe putting a bit of texture also on the stem, because we saw like as it was growing, the texture was changing, especially on the pedestal connected to the fruit. We could see this.
Yeah.
So maybe putting a bit of texture would also be nice.
Okay. Great. And finally, David?
Yes, so I wanted to have a model of carrot, and so I started going to the market and get a carrot leaf, and you can see here. So on order 0, we've got opposite growth of branches, and then on order 1, 2, and 3. We've got alternate branching, and so this is the very perfect leaf, and then I wanted to have it more realistic, so I added some noise. Now we have the leaf with a much more noisier pattern, and we want 4 leaves, let's say. And so that's a plant with 4 leaves, but it's flat, so we want some tropism, and here we put some vertical tropism to the upward to the beginning of the leaf, and then random but on the direction of the axis of the stem for a while, and after at the end we want tropism downwards to fake gravity. And so here we have a carrot, and we can generate random carrots at will, which will have different appearance. Like you see here, I can have many carrots, and so the next step is to make a field of carrots, and here, so yeah, we can have a culture bed of carrots, which is the beginning of a virtual farm, hopefully.
Virtual crop at least.
Yes.
Okay. And you need a bit of randomness here as well.
Yes. This was with earlier model, so
Okay.
so yeah, I need to.
Okay. By the way, there is a command that we didn't use. I don't remember whether I introduced this to you, but there is the possibility of reusing interpretation rules in different files just by doing this past file of the file number, and then in this file you just put the interpretation rules, and then you include it with this command, %pass5, and the name of the file. And then you may reuse your interpretation model in many files, in many LPy files. So it's a way to share common models between different between different LPy models.
Okay.
Okay, so beautiful. Questions to David? So do you think after the field and what you presented, you are finished with the Carrot model, or do you have other improvement in mind?
I'm thinking mostly of letters now, so...
Okay. Carrot was too easy?
Carrot is good enough, at least for what I want to use it. But yeah, well, like I kind of simplified the development of the Carrot, like you saw in the animation. It's not so realistic in terms of development, so there would be some improvement to make the development more realistic.
Realistic. Actually, it might be useful because if you want that a robot is looking at the crop at different stages of the development of the crop, maybe if you have younger stages where it's more realistic than maybe the one that you have at the moment, it might help for the system to be trained by this type of carrot crop.
Yeah.
Or even the robot in the virtual field to recognize the carrot on a more realistic basis.
Yeah.
Yeah. Okay. Other questions? That's okay. Okay. So I think we are done. Good work, I must say. I'm quite impressed by either the problem that you struggled with and the way you could struggle with the problem and the different ideas. You were not discouraged, at least, to continue and to proceed further. And some of the results are already quite impressive visually. So if our aim was to get to this point where we are able to produce realistic plants in 3 dimensions to train machine learning systems, we are on a good track, I would say. Okay, so thank you very much, everybody.
Thank you, Christian.
Thank you.
You're welcome.